Good morning, mathematicians. Today we are going to do a little throwback to solving systems of equations, except we are going to involve quadratic functions, but we're going to solve them algebraically and graphically, just like you guys did when I first introduced them to you. When you guys learned this back in, I think it was maybe December, you guys had two linear functions, and that's what you dealt with. You graphed them, or you solve them algebraically. Like, that was always the case. Today we're going to look at one of them being a quadratic and then the other one being a linear function. So for your do now, I'm asking you guys to consider those functions and solve them graphically, which underneath here I do have a graph. I understand that you might not have it at home, so instead of me just showing you right ahead like the answer, I'm going to show you how I got the graphs there. So since it's saying graphically, the first thing we should be thinking is, oh my god, where is my graphing calculator? And we're going to type in the function. So I have x squared minus 8x plus 15. Nope, that says 25. Plus 15. Always make sure you type it in correctly. So I have x squared minus 8x plus 15, x squared minus 8x plus 15. So I want to know what my graph is going to look like. If you're interested, you can obviously hit graph, and I already know, like, holy cow, I have a quadratic. It should be a U shape. I don't see a U there. So if I go to zoom and then scroll down to standard, I get more of what I should be seeing there. And again, I never want you to just draw a curve. I know if I hit second graph, I get all of these table of values that I can plot. So 0, 15, yeah, that's not going to fit on my graph. So I'm going to start with 1, 8. I'm going to keep scrolling actually until I see my turning point or my vertex. And now I know here my turning point is 4, negative 1. Because again, my y values start to repeat. I see 8 here, I see 8 there. I see 3, I see 3 here. So it has that pattern. So I went ahead and graphed them on my grid here, all of those points. Then the blue, that's what I have there in red. That's how I labeled it for you guys. I could actually change this here and make that red. What you see in blue there, that's your linear function, which is x plus 1. So I did the same exact thing. They said to solve it graphically, so I went ahead and typed that into my graphing calculator and hit second graph and got a beautiful table of values and then plotted them there. Both of these graphs should have arrows at the end because it's just saying graph. It doesn't say over a set interval. So now it comes down to, like, solve this system. I want to know what are the solutions. So in order to find my solutions, we haven't done this in a while, a reminder, that's where your two graphs are intersecting. So I see one of my solutions to be here, and then I see my other solution to be this point here. So those are my two solutions here, which is going to be 2, 3. It's so hard to write on this. 2, 3. And then my other point is this one here, which we're going to solve next algebraically to confirm it. So that was graphically straightforward, straight calculator question. Oh my god, thank you New York State whenever you put a graphing calculator on the regions for you. But we're bigger and better than that. So let's start looking at, if I said to you guys, solve it algebraically. So once they say, again, algebraically, you already know in your head, hey, I have to show some work in order to get credit there. So now I'm asking you, of the two algebraic methods we learned, what's the only method we can use to solve this system? I know this is a system because I have more than one equation. So there was two methods we learned. I'm going to call on Caitlin and Ashley, who are going to tell me that the two methods we learned are substitution and elimination method. So those were our two methods in fact, but I can only use one of them in this case. So the one that we want to use, Yes, Irving, the one we are using in this case is definitely going to be substitution. So I have them written on my whiteboard here. So you might be wondering, like, okay, how do I know I need to use substitution? Well, if I look at how my equations there are written, I have my quadratic and my linear function. They both have y equals. So since that's the case, that totally allows me to take one of my functions and substitute it in to y for your other. So like I can take x plus 1 and I can substitute that in for y because this is saying y is equal to that. So if I completely erase this y and now substitute that in for it, I'm going to have x plus 1 equals x squared minus 8x plus 15. So I literally just took this x plus 1 and substituted it in for y because that's what it's saying it's equal to. And now you have an equation that you know how to solve already. This is what you guys were doing on Friday when you had, Thursday, two variables on the side of your equation. So the first thing you had to do was, let me set both of my equations equal to 0. So how do I do that in this case? Well, I'm going to subtract x and I'm going to subtract 1 because both of those are positive and I have to do the inverse operation. And I'm going to combine them with those like terms over there. So I'm going to have x squared minus 9x plus 14. And now this entire thing is equal to 0, which is what we wanted. Oh, great question, Sam. Where did this negative 9x came from? Well, remember, that was negative 8, and this is like a negative 1x there. So I just combined those terms together. Don't forget that's like a negative 1. Now, if I said to you, hey, we want to solve for x here. Oh, Joselle, thank you so much for telling me that I need to use ABC method. So I'm looking at my C value, which is 14. We love factoring. And I'm going to start listing those factors like, okay, 1 and 14, 2 and 7, negative 1, negative 14, negative 2, negative 7. And which of these pairs here are going to add up to a negative 9? Yes, Joanne, it's definitely going to be negative 2 and negative 7. So I'm going to have x minus 2, x minus 7 equals 0. It's totally fine that I just put the equal 0 on this side. It means the same exact thing. Do not stress out. So Mario, now that I want to solve for x, you're absolutely right that I would split each of my factors here and set them equal to 0. So I have x minus 7 equals 0. Oh, I definitely have to add 7 to both sides to isolate x. And here I have x minus 2 equals 0. Oh, I absolutely have to add 2 to both sides here. So I have x equals 2, x equals 7. And now you're left to solve for your y values. Well, again, I'm solving a system of equations, so how do I find my y? Ricky, you are right. I do substitute in for x. So I'm going to use the y equals x plus 1 because that's easier. So I simply would have y equals 2 plus 1 or y equals 3. And here I would have y equals 7 plus 1 or simply y is equal to 8. And remember, these are ordered pairs. So my ordered pair here is 2, 3. Oh, that's so crazy. That's what we got over here. What a full circle. Here I have 7, 8. Oh, that has to be this ordered pair over here. And that's it. You're solving systems of equations, but we're just focusing in on substitution method. So here, let's look at this other example. I want to find 2 points of intersection of the quadratic and linear function shown below algebraically. Again, no worries. The second I see algebraically, all that means is I just need to show some work to support my answer here. So I have f of x equals 5x plus 3, and g of x equals x squared minus 3x minus 17. And I have that over here for us. And I want to solve. Well, again, we can only use substitution here. But I'm looking at this and I'm like, oh wait, this says f of x and that says g of x. Is that really the same thing? So I'm going to ask you guys, is that really the same thing? Maria, you are absolutely right. We know that f of x, that's just a fancy way of saying y equals. And I know g of x, that's just a fancy way of saying y equals. So in fact, it's not like I don't even need that there. That's just another way of saying y equals. And now you can go ahead and use your substitution method. So maybe I'm going to take now 5x plus 3, because that's what y is equal to, and I'm going to substitute it in for that value here. And I'm going to have 5x plus 3 equals x squared minus 3x minus 17. And now again, I want you to solve for x. So what's my first step here going to be? Anytime I see a quadratic function. Oh Maya, you're absolutely right. I need to isolate my quadratic. I need to set everything equal to 0. So I'm going to perform my inverse operations to move all my values to one side. And then I'm going to combine like terms. X squared minus 8x minus 20. And look, we have it equal to 0. Now I want to solve for x. How do I solve for x here? Oh, I know since my highest power here is 2 that I have a quadratic function. And the only way to solve quadratic functions is by factoring. So Tammy, I absolutely should be using ABC method. And I'm going to look at my c value, which absolutely is negative 20. We know that that negative is part of it. And I'm going to start listing my factors like negative 4 and 5, negative 5 and 4, negative 10 and 2, negative 2 and 10. Yuri, you're absolutely right. We should be using x minus 10 and then x plus 2. And I have that equal to 0. And my last step is to split and set both of those factors equal to 0 in order to solve. So I have x equals negative 2 and x equals 10. But remember, we're not done because we're talking about solving a system here, which means that these are forming ordered pairs. So I need to figure out like, okay, what is my y value here going to be? So I'm going to take each of my solutions and just substitute it into one of my equations above. So I'm going to have 5 times 10 plus 3. I'm using the linear equation because I think that's easier. And holy cow, that's going to give me a y value of 53. So I know that this ordered pair here is really 10, 53. And then I have x equals negative 2. Well, I'm going to have 5 times negative 2 plus 3, which is going to give me y is equal to negative 7. And again, that ordered pair is negative 2, negative 7. I can even like triple check my solution here by going into my graphing calculator, typing in my two functions. So I have x squared minus 3x minus 17. And then I have 5x plus 3. I don't even care about the graph. Let's just go to second table and look at those values. So at negative 2, notice both of those y values are negative 7. So that's definitely a solution. My other one we found was 10. 53, 53. And that's how you know you're correct. All right, rock stars, the rest of it is yours. You are just practicing solving algebraically. Have fun, enjoy.